Hello everyone, and welcome back to another video. And today I want to give you an overview of a very exciting GTX 680 card that has been pretty much designed exclusively to be overclocked. Well, it's one of those. So this is the EVGA GTX 680 classified, specifically the hydrocopper version. So they come with a water block like this, and yes, I have two of them at the moment. Not gonna keep two of them. That one, the one with the water block, is going to a friend of mine. However, I will be keeping this one. And I can distinguish them because this one got some shipping damage and this DVI port is now not as straight as it's supposed to be. Yeah. I've already tested both of them. And they are pretty much identical. The only thing is, like, this one has a very slightly worse core. It's literally just one clock step, so 13 megahertz difference. So I'm gonna call that exactly the same, because at that point it might as well be like a small temperature difference, and then you drop a clock step. Yeah. So both of these have been doing very well. So I tested these at 1.175 volts, which I think should be somewhat resembling a stock voltage card, but without a power limit. So I think 600 series cards should be around 1.175 volts at like stock voltage, but without a power limit, because with a power limit they throttle down and then voltage goes lower. And I also tested these at 1.3 volt, which is not the highest that this card can go. With the Classified 2 you can go all the way up to 1.65 V-core. But like for the sake of comparing to other Kepler-based cards, 1.3 volt is like, yeah, you can do 1.35 even on reference cards, but like that's really pushing it. And like you should need water cooling at that point. 1.3 you might be able to get away with like air or like a custom air heatsink. So that's why I chose 1.3, because it's like it's up there but not so high that only overclocking cards can do it. Yeah. So at 1.175 volts, both of these cards did 1306 megahertz, which is decent. However, it's actually not the highest. I have a reference 680 that actually did 1320, so one clock step ahead at stock voltage. However, I don't know if that was exactly 1.175. That's only my estimate, not like it's based on some older measurements, but I didn't exactly verify that it's exactly that amount of voltage. And then at 1.3 volts, this slightly weaker card did 1411 megahertz, and then the slightly stronger one did 1424 megahertz. So that's pretty good. I don't know what my reference card does, because I only tested that at 1.35. And at 1.35, that reference card actually did 1500 megahertz. I wasn't able to get any higher than the 1.3 volt numbers on these cards, because right now it is very hot. This is early morning. It is early morning right now. This is gonna go way higher. The last 1.5 weeks have been essentially 30 degrees ambient, and even with water cooling, these cards just run too hot to go any higher. Like at some point, like I noticed that with the other 680 as well, at some point there's just like a wall where you just need to go colder, and no amount of voltage is gonna fix that. So I wasn't able to run 1500 or anywhere near 1500 actually on these cards yet. However, should it go colder, which I hope it's gonna be soon, because if it's so hot, I'm also not gonna be bothered to run dry ice, because I'm just gonna get a lot of condensation with the big difference between ambient and anyway, like, yeah. So I wasn't able to get that high core on these yet, which is probably because of ambient temperature. And then for memory, both of these cards did exactly the same, which is, it was 3950 megahertz in MS Afterburner, which should be 1975 megahertz in actual memory clock. I think it's 1975 megahertz, yeah. So pretty decent. You can't quite get to 2000 on these, because the Samsung memory modules which is Samsung D-Die, if you wanna, like that's the Samsung memory modules are always so hard to read off. You can kind of see that D there before the dash. So this is Samsung 2GB D-Die. And yeah, like these scale with voltage and they go pretty fast compared to the Hynix MFR. And I think also AFR modules that 600 series cards came with. There were in 700 series there were some AFR and also BFR cards that did 2000 no problem. But the ones you got on 600 series, I have not seen one that did anywhere near what these Samsung cards are doing. So this is pretty good. However, compared to 700 series, this is not that great. And also these cards are 4GB. So a normal 680 has 2GB, and well, these are 2GB modules, so they have 256 megabytes each, and you have 8 on the front, so that only makes 2GB. And then on the back, which recently became the norm again with the RTX 3090, you have more memory chips, and you can kind of see the thermal pad. So there's another 2GB on the back, coming to a total of 4. So basically what that means, this card is also competitive in like Firestrike Ultra and Times by Extreme, because those tests, yeah, like you just can't run them on 2GB. Like they need so much memory that a 4GB card is just always gonna be the 2GB card, no matter how good the actual clocks are on the 2GB card. So yeah, I could do some Firestrike Ultra, or well, I don't know if I'm gonna bother with Times by Extreme, because like it's DirectX 12 and it doesn't really run well on Kepler. But Firestrike Ultra is an option with these, and yeah, like I mean, they've been clocking pretty great so far, and it's not like the PCB is bad. Like it's really good. It's a really good PCB. So let's get into that. So this being an EVGA classified card, it's using the signature 14-phase IR direct fed VRM that pretty much any classified EVGA card has, from the GTX 580 all the way to the GTX 1080, also including the Kingpin cards in that range. They all have this very same 14-phase V-Core VRM, and I'm not sure about memory, but I think most of these also have this 3-phase memory VRM. Output filter and controllers do change a bit. However, they're like, well, it's always a high-end controller paired with a pretty substantial output filter, but it does change from card to card, mostly because like different GPUs need different kinds of output filtering and also run on different voltage specs, so you have to change the controller at some point. So for the GTX 680, the controller is a CHL 8318. It should be running in 7+0 mode, and then we have a bunch of doublers here. I wasn't quite able to see what these are, but considering that, I mean, Chill is owned by International Rectifier, and these are International Rectifier MOSFETs, and considering that the IR3598 is a pretty popular doubler, I'm gonna guess that these are IR3598s. Like you can see the IR logo on it a bit, but I can't really. I can't see the 35.9, but I can't see the okay. At this point, like there's also 3599s, but I think those are too new, or like this card is told. So these gotta be IR3598 doublers. So that's how you get 14 phases. Yeah, and then also your memory is a 3-phase controlled by this controller, which is some UPI controller. And yeah. So, MOSFETs for the VRM. The high-side MOSFET is the International Rectifier IR6721, and the low side is the IR6725. We have seen these MOSFETs before on the GTX 580 Lightning and also the HD 7970 Lightning. Like, they are a pretty popular choice for International Rectifier direct feds. Like basically the thing about these is, like you can see though, this is a more normal package for the discrete MOSFETs, and this is like the IR direct fed package. So you can see these are silver shiny because these actually have an exposed drain. Like this metal piece is actually the conducting part of the MOSFET. Whereas on normal MOSFETs you have everything internal and there's like a plastic package on it. This is actually just the conducting component of the MOSFET, which means that it's directly exposed, and if you put a cooler on this, you're cooling the internals of the MOSFET. Well, it doesn't really have internals because there's no package around it. Like you're cooling the circuitry of the MOSFET directly and not through a package like you would do normally, which means that these can be cooled down a lot more efficiently than most other MOSFETs. And that helps a lot because these MOSFETs, when you keep them cool, they have an absolutely ridiculous amount of current they can handle. But it drops off rather fast when they get hot. So you do want to keep these cold. Yeah. I mean, it's not, this VRM is probably fine just running completely naked because this is a GTX 680. Like, it's a GK104 core. And the funny thing about this is only a GTX 680 because AMD wasn't keeping up. Like, it's different today because NVIDIA cards don't really improve over time, but AMD cards improve over time. So now the HD 7970 and 7950 pull much higher scores than this did. But when it came out, this was pretty much just the fastest card, and AMD had nothing to compete. So even though NVIDIA could have built a bigger GTX 680, they didn't, and only used that bigger core that would have been the 680 in a parallel universe where AMD had been keeping up for the Titan first, and then later the 780 and 780 Ti. So theoretically, the 780 Ti would have been the 680, the 780 would have been the 670, and then this, which ended up being recycled as the GTX 770, would have been the 660 Ti or normal 660. So essentially, this is a 60 class GPU in an 80 class graphics card on an 80 class PCB, because this is the same VRM that's powering the GTX 580 classified, which is a very, very big power-hungry GPU. Well, okay, Kepler can pull a lot of current, current and power. Kepler gets very hungry if you really push it. But if you don't really push it, this GPU just consumes nowhere near the amount of power that Fermi did, or big Kepler later did, or big Maxwell. And well, Pascal is also like, because the 1080 Ti did have a different VRM, but the normal 1080 did still have this VRM. That's also another case of, yeah, doesn't really need this PCB. So yeah, this VRM is pretty much overkill. You also see that from the other cards, like the reference GTX 680 literally has a 4-phase. So this has 10 more phases than reference. And also one of the competitors for this card, which is the GTX 680 Lightning, which is just MSI's counterpart to this, that came with an 8-phase, which this is still almost double of that. Yeah, this is 2 phases short of being double. So, yeah, I don't actually... Oh yeah, Gigabyte had the 680 SoC. That one was also on an 8-phase. So, yeah, like, while most other manufacturers like custom build PCBs for a specific GPU, EVGA just kind of took the same VRM they've been using for Fermi and copy-pasted it onto this GTX 680, resulting in this rather ridiculously looking PCB. Like, yes, everything up here is empty. And it like, this core is barely bigger than one of those memory modules. That's kinda... yeah. But this also means that this is a very fun card to overclock, because one thing that's kinda annoying with overclocking like high-end GPUs is not essentially how much power they draw, just because how hot they get, which means they are sometimes rather hard to cool, especially Fermi, because Fermi draws so much current, you gotta keep it cool or you're not gonna get anywhere. And yeah, so basically big GPUs are kinda annoying to cool down sometimes, because some GPUs you need to cool down to get any gains. And then the other part is VRMs sometimes get pretty hot, which is probably not an issue, but it makes me uncomfortable. Like, VRMs can get like that's the thing. Technically this VRM would be fine running at like 105 degrees. It wouldn't be the best for the capacitors, but they would probably be fine for a while at least. But yeah, like that's the thing that I don't really like about high-end GPUs. It's just like the amount of heat you have to deal with. Since this is a 680, that's not really a problem, unless, as I said, you really push it, because this thing is totally capable of sucking up 350 watts, if you really push it, that is. But in the more normal range of not going to 1.4 volts, this is far more manageable than, say, a 780 Ti or a 580 or a 480 or even a 980 Ti. I don't know that much about Maxwell. Like, I had a 980 Ti that I gave away to my sister because she needed a new card to play games on, and I had a 970. I still have that 970, but that one just, it has an awful core and an awful memory, and I just don't like it very much. Like, I don't like running it very much. I still like the card because it's the first e-power I ever pulled off that worked. But yeah. So GTX 680s are very fun. And this PCB is just the right amount of overkill so that, yeah, this basically, like, the limit of this card will be the silicon. It won't be the VRM or like anything else. Because on like GTX 480 and 580 reference cards, you run into VRM limits. Like, at some point the VRM just can't handle more voltage without blowing up. And like, yeah. Whereas this, you can pretty much strap any cooler you want to this, and the only limit you're really gonna run into is, can the core just not do anything? Like, it can it just not do anything more? So yeah. I think let's talk a bit about some other features of this card. We have triple BIOS actually. So there's a switch here, and as you can see, that's like right position, and it's rather hard to turn, middle position and left position. So this is triple BIOS, and as is reflected on the back, you have 3 LEDs here, and like you can see, it says LN2 OC normal, and then there's an LED lighting up that corresponds to these. I've been running both cards on the OC BIOS, which so like is just middle one. Yeah, also these come with a backplate. I haven't mentioned that. And also there's a lot more output filtering on the back. Like, this should be memory, and then these, there's more core. What's under the backplate is just loads of rows of multi-layer ceramics. But yeah, you can't really see that, but like, the output filter on this side is only half of what you get, basically. Well, not really, like, you don't get can types on the back, and you don't really get SLE polymers. Like, you get a lot of multi-layer ceramics on the back, so basically, if you were to complain that this doesn't have enough multi-layer ceramics, well, look at the back, because there they are. Other features of this card, yeah, you do have some probe points here. This is kind of similar to the voltage read points that the MSI cards have, just that this kind of needs a very proprietary connector, which I do not have, sadly. So yeah, won't be able to really probe voltages on this, but I'm not really too upset about that. And also you have some LEDs here that indicate if all your rails are running. So if you should ever have a problem with this card, it should be relatively easy to troubleshoot, because one of these LEDs or multiple are not gonna light up, and then you know what's wrong with it. But I think, yeah, these are not labeled, sadly. Yeah, these are not labeled, but I guess you can find out somewhere what these mean, and then you can, like, oh, this is not running, like 5-volt regulator died or something. So it's kind of handy. Then you also have this, which does look suspiciously like an I2C port. So you could hook up an Elmore EVC to this and talk to the CHI-8318, and potentially also the memory controller if that's supported. However, I don't think that will be necessary, because, well, there's no overcurrent protection here to live, because this VRM... The VRM is going to destroy the core, not the core destroy the VRM. And also you have the classified tool, which can adjust both core and memory, as well as both the PEX rails, because for some reason GTX 680s have 2 PEX rails that are all at the exact same voltage. don't know why, but it's a thing. So you can adjust these 4 rails in the classified tool, so don't really need an EVC, but you could, I guess. Like, I haven't verified this is an I2C port, but like, what else would this be? So, yeah. And I think that's mostly it. Like, yeah, it's just a very overbuilt GTX 680 that ended up looking like this, likely because EVGA expected to see a GK110 based GTX 680, but then we got a GK104 based GTX 680. So, yeah, but it's not that I'm complaining, it's just why it looks rather weird, with this tiny core and this big VRM. But yeah, like, this card is gonna be very fun to overclock. Like basically all over the HW board ranking you see these and the Lightning cards, mostly because those are like, well, actually I don't know if these even came in 2 GB versions. But like basically, like, you need a 4 GB card to be competitive in Firestrike Ultra and Time Spy Extreme. And well, like, my reference card is proving that you can get pretty far for GTX 680s on reference PCBs. However, I have not used dry ice or liquid nitrogen yet, and that could change very quickly, because at some point that VRM is gonna hit its current limit and it's gonna blow up. This will not. So yeah, and also just these have a much better output filter. And my reference 680 scaled a lot when I added more capacitors to it. So, yeah, like, and I will always respect those who get cards and mod them and then get good scores, more than people who just buy one of these and get high scores with them. However, I can see the appeal of this, and I mean, I myself have a card like this now, because they're just great. That's basically it. And yeah, so any more plans with this? So this is gonna see dry ice, of course. It's just like, as I said, the ambient temperature is very high, and like when I'm hot and miserable, I don't really like to bench as much, especially not like janky setups like dry ice or water. I've actually stopped using my water cooling loop for most of things, because I noticed that the ambient is so high now that basically it doesn't make a difference if I water cool it or just use a lot of airflow on air. So I just stopped bothering with water cooling for now until the ambient temps go lower. So yeah. But nonetheless, yeah, this card is great. I'm happy to have one. I guess my friend will also be very happy to have his card once I can eventually send it over. Like, he's also getting the Rampage 3 Extreme, he's getting a Ryzen CPU water block, he's getting an E-Power I made for him, he's getting a GTX 480 block. Like, I have a bunch of stuff for him, and I guess it's time to send it over. Yeah, and like, I hope he'll also have a lot of fun with his card. And I think that would be it. We overshot 20 minutes by quite a bit. So yeah. I guess I'm just gonna end at this point, and yeah, thank you for watching, hope you enjoyed, and until next time, goodbye.